and has a slope of 2. Yeah.
Before we even look at your multiple choice, we don't need multiple choice.
Yeah.
There is a point-slope equation that this is perfect for, because we have a point and we have a slope. What is the general format of the point-slope equation?
Isn't it y1 minus y2 over x1 minus y2?
Well, that's close.
Oh, yeah.
What you gave me was just slope.
Yeah.
y2 minus y1 all over. In other words, you gave me rise over run.
Yeah.
Well, there's a general format. There's also y equals mx plus b. Both of these are general formats for the equation of a line. And the slope is that. But since we know one full point and we know the slope, let's use the simplest equation we can find. Number 1. What is y sub 1? What's this point?
5.
Exactly. What's m?
2.
What is x sub 1?
1.
There's the equation of the line. Now, if they say that they want that equation in slope-intercept format, then you would have to... Do they say that?
Yeah, they do.
Okay, well, let's put it in slope-intercept format. Slope-intercept format means we need y on one side, everything else on the other. So what's the first step?
Add 5, both sides.
All right. I don't like that first step, but
sorry. Distribute
you
the
can
2x.
do either one. It makes more sense. In other words, this is now correct. Now distribute the 2. What do you get?
2x minus 2.
What's the final equation?
Y equals 2x plus 3.
There you go. Now, there's another way to do this, and let me just show you what it is, just so you won't be confused. In other words, if they ask for this format, which apparently they did, well, I can start with using this and solve for b. In other words, I know an x and a y, and I know the m. So let's substitute 5 for y, 2 for m, 1 for x, and we'll be able to solve for b. And this actually gets it a little more directly than the first method did. 2 steps. So it kind of depends on what they're asking for. If they ask for just the equation of the line, the quickest method is this. If they ask for the equation of the line in slope-intercept format, quickest method is this. Both of these are the same, incidentally. They both describe the same equation of a line.
Okay.
All
right. I just sent you an email of another problem.
Okay, let me open it up. All right, another classic algebra problem. more than geometry. If you know 2 points, there is only one line that can run through those 2 points. Let's graph it. Here's 2, 1, and here's 0, -5. If I connect those 2 points, there's only one equation that describes that line. In other words, that's all you need is 2 points.
Okay.
Or slope and 1 point. Both give you enough information to describe that line. Now, the fact that they've given us 2 points, what's the slope? That's the most important thing about a line, is the slope, incidentally.
Once you do x minus x and then y minus y.
Remember, it's rise over run.
Oh, yeah.
Well, that's the rise.
Yeah.
That's the run.
Mm-hmm.
What's the rise in this case?
4? Or -4?
What's the distance between that and that? If I were to graph it on a number line, how far is it from -5 to 1?
Oh, 6, isn't it?
Yeah. Okay, so if I do it the technically perfect way, which is -5 minus 1, I get -6 as the rise. What's the run?
2.
-2. You have to do it in the same direction. In other words, you cannot do -5 minus 1 divided by 2 minus 0. That's going in the opposite directions of one another. Okay. If I'm going to do -5 minus 1, then I've got to do 0 minus 2.
Okay.
That gives you -2 in the denominator. And the sign is more important than the number. If you don't get the sign right, you're not getting the problem right. So what is -6 divided by -2?
Isn't it 3?
That's the slope. That's always the most important thing you can calculate is the slope. So now we have m equals 3, and we have 2 different points. We have that point, and we have that point. Well, remember there's a format for slope point, which is where you have exactly the slope, and you have the point, and you can choose any point you want. What's the format for point slope?
It was the one you just did.
Right. What is it?
Y minus something, and then it has the parentheses with the slope in front.
All right. If you want to remember this,
have it written down somewhere.
Well, no, let me give you a clue for memorizing this. Divide both sides by x minus x sub 1.
Okay.
Well, what is that? Slope? That is rise over run. In other words, the only thing you really have to memorize is rise over run. If you memorize rise over run, you'll never miss it.
Yeah.
Okay? So,
I have it memorized.
Okay. Well, there's your formula for rise over run. And we know the slope, and we can choose either of these 2 points. Which one should we choose?
2 and 1, I guess.
Yeah, because they're both positive numbers. If you can avoid negative numbers, do so. Always. So, plug in the slope, y sub 1, and x sub 1 into this equation. What do you get?
Y, can you go up? Yeah, 2 and then, so Y1 and 2 and X2.
What is Y sub 1?
Isn't it 2?
It,
Or 1, sorry. 1.
Exactly. That's the Y coordinate is 1. What's the slope?
3.
What is X sub 1?
2.
There's your equation of that line. Now, once again, if they didn't specify the format that they wanted it in, well, all of our answers are Y equals. So let's solve this for Y. What do we get?
So we could go
This first step,
1,
let's distribute.
3x minus, or 3x plus negative 6.
Hold on, it's 3x minus 6.
6, yeah.
Now add 1 to both sides.
Add it to 6, 7.
When you add 1 to negative 6, what do you get?
3x minus 5.
There's your equation. That's the answer we should look for. It's right there.
Okay.
Okay. What else? It might be, if it's a problem you can verbalize, go ahead and do so if you don't have to send it to me. That problem we actually could have verbalized just fine.
Okay, hold on, give me a sec.
And it's actually good practice for you to verbalize problems, Ellis. It really is. It's something you don't get to do a lot of in class. I'm guessing. How often do you get to stand up in class and verbalize a problem?
Never.
Exactly. So let's give you some practice doing that. It helps. It helps in understanding math.
Okay, let's see.
As long as it is a problem you can verbalize. In other words, if they're showing you a graph or a shape and they're asking you questions about it, then that's something we need to look at. But if it's the algebra problems that are like the ones you've been giving me, you can verbalize those.
Alright, so it's solve the system.
Okay? What's the first equation?
2x minus 3y equals negative 14.
It's the second equation.
3x plus 3y equals 9.
All right. There's a rule that you can add or subtract any equations.
Okay.
If I have a plus b equals c, and I have x plus y equals z, then I can add these two equations such that a plus b plus x plus y equals c minus z.
Okay.
I can also subtract any two equations. Excuse me, that was c plus z. But if I wanted to subtract these two equations, I could also do that. So that's an important thing to know. You can always subtract or add any two equations. In other words, add the left sides, add the right sides, or subtract the left sides, subtract the right sides. So, what you've given me is a problem that can be solved by elimination.
All right.
Elimination means eliminating a variable. So what can I do to these two equations to eliminate a variable? My two variables are x and y. Can I either add or subtract the two equations and eliminate one of the variables?
You could subtract, you could do the y, you could eliminate the y.
You could just add. In other words, if I add those two equations, what do I get? How many x?
5x.
How many y?
0.
And how much number?
5 or negative 5.
Negative 5. Well, this I can eliminate. So now I have 5x equals negative 5. What's x equal to?
1. Negative 1.
Now that I have x, I can go back into either equation and solve for y.
Yeah.
That's always the second step. And the one I chose was, the only reason I chose that was because there were no negative signs in it.
Yeah.
Okay, so we've solved for x. We know what x is. X is minus 1. How do I solve for y?
So it'd be negative 3 plus 3y equals 9.
Next step.
And then you can add 3 to each side. Or you can do that.
Last step.
Divide.
There's your solution. Okay? Now, there's lots of ways to solve simultaneous equations with two variables. There's the two they've taught you are substitution and elimination. The reason I chose elimination was because both were in standard format, which is to say that the x and the y are on the left side, the numbers on the right. If instead I had this sequence where they give me this one, but then they say y equals 9 minus 3x divided by 3. In other words, if they were to give me the problem like this, I wouldn't choose the same method. I wouldn't choose elimination. I would choose substitution. Because one of the variables, y, is completely defined. Even though I didn't simplify it. Let's go ahead and simplify y. So y is actually equal to 3 minus x. But the same thing, y is fully defined. So if I go back into that equation and say 2x minus 3, well, what is y? Y is 3 minus x. If that's equal to minus 14, now notice that I have one equation and only one variable. Yeah. I'm going to be able to solve for x. You can always solve when you have one equation and one variable. If you have one equation and two variables, you cannot solve it. If you have two variables, you have to have two equations. For me to solve this, distribute the 3. Combine the x's. Move the 9 to the other side. Again, I get x equal minus 1. Same answer. Now, to get y, I go into that, and if I plug in minus 1 for x, I get y equal 5. So I get the same two answers as I got before. It's just a different method of solving for it. And the method that I'm going to use is going to depend on how the equations are presented.
Yeah.
All right, we got time for maybe one more. What else you got?
All right, I just sent it to you.
Okay. All right, whenever you get a problem like this, the thing that will always clarify it is if you graph it.
All right.
First point, 1, comma 2. And I don't need to go to the trouble of labeling my grid. I just don't. I can approximate 1, comma 2. That's about there. 8, comma 2. Well, 8's way over here. It's the same vertical height. We'll call that 8, comma 2. And the third point is 3, comma 6. Well, 3 is somewhere between 1 and 8, and 6 is way up here. They want the area and the perimeter of that triangle. What's the distance between, let's label that A, B, and C. What's the distance between A and C?
Wouldn't you just subtract the x's and then the y's?
Just the x's. The y's are the same.
So it'd be 7.
Okay, so that's 7. The area of a triangle is, what's the general formula?
Base times height divided by 2.
I prefer to think of it as that.
Yeah.
Same thing, but it's easier to remember if you start with the 1/2. Okay? So, if I can figure out that height, I know my base is 7. So the area is 1/2 of 7. What's the height?
2.
What's the distance between the y coordinates?
Wouldn't it just be 2?
6 minus 2.
Oh, sorry, I was looking at, yeah, 4, sorry.
That's okay. It's important you understand that. There's 6. There's 2. The height of our triangle is 6 minus 2,
Yeah.
which is 4, which means our area is 14.
14.
Now, they want the perimeter also. And that's quite a bit trickier, actually. In other words, in order to get the perimeter, we need to know the length of AB and the length of BC. It was very easy to get the length from B to the base. So all we had to do was subtract the y coordinates. But to actually get the distance from A to B, what is the distance formula?
I don't know it.
Well, think of the Pythagorean Theorem. It's always going to be the hypotenuse of a triangle. So it's always going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. In other words, it's the Pythagorean Theorem. So what is x sub 2 minus x sub 1? We're going from A to B.
Okay, so it'd be 1 minus 3?
Well, avoid negative numbers. You can always go the other direction as long as you're consistent. In other words, you can go 3 minus 1 as long as you go 6 minus 2.
Alright, so 3 minus 1.
Squared.
Squared, and then plus 6 minus 2 squared.
So that's 2 squared, 4. That's 4 squared, 16.
So it'd be 20.
Square root of 20 is this side. Now let's do the same thing for the distance from B to C.
So it'd be 8 minus 3, so 5, and then negative 4.
Very good. And notice that when you square it, It doesn't matter whether it's positive or negative.
Yeah.
So it's the square root of 25 plus 16, the square root of 41. So that's that distance. So what's the perimeter? We know all three sides.
How would you add the squares?
Because this is an irrational number, and that is an irrational number, we don't combine them. We list it as 7 plus, well, square root of 20 is the same as square root of 4 times square root of 5, which is actually 2 square roots of 5. So 7 plus 2 square roots of 5, which is that dimension. Square root of 41, that's as simplified as you get. There is your answer. The perimeter is 7 plus 2 square roots of 5 plus square root of 41.
Okay.
Now, you're getting to a point in mathematics where you don't convert everything to decimal. In other words, if I wanted the most exact answer I could get, I've just circled it. That's it. If I want an approximation, then I'll go into my calculator and figure out what 2 square roots of 5 are and what's the square root of 41 and add it to 7 and come up with a decimal approximation. But it's very important that you understand that if I convert this to a number, it's an approximation. If I leave it in the radical form, it's precise.
All right.
We're getting to a point in math where we want to be precise. So I'm going to leave it like that.
Okay.
All right. We've gone a half an hour. Are you good to go?
Yeah, thank you.
Yeah, you're welcome. Anytime. Here, let me tell you the best way to reserve a session. If you go to this website, you will be able, it's tutor.com, you'll be able to see my full schedule and reserve a session online if you like. You'll also be able to pay quite easily.
All right.
So digitalmathtutor.com.
All right.
It'll save you having to make a phone call and saying what's your availability. Because if you go there, it shows you my complete availability and lets you make appointments.
Okay, thank you.
And it also allows you to pay. If your mom has I know she's paid by check in the past, but if she has a PayPal account, it's actually quite a bit easier to pay by PayPal.
Okay.
You might want to tell her that.
Okay.
She's certainly welcome to send me a check. I'll send her an invoice. But in terms of scheduling, if you need help at any point in time, go to this website. You'll see my schedule always.
Okay.
All right, Alice. Talk to you later.
Thank you.
You're welcome.